This is Prakash in front of you. I hope that you are all safe along with your parents. I feel very happy to meet with you through the online classes. Now we are going to new chapter. Introduce a new chapter, structure of atom. In the earlier class, we learned about the subatomic particles, electrons, protons, neutrons. Electrons are having negatively charged particles, protons are having positively charged particles, neutrons are chargeless particles. In earlier class, 9th class, we learned different types of atomic models. J.J. Thomson atomic model, Rutherford atomic model, Bohr's atomic model. Now, some questions raised. The questions are, first one, do all atoms have same subatomic particles? Second one, why is the atom of the element is different from the atom of the other element? Third one, how the electrons are distributed in the space? Once again, I repeated these three questions. Do all atoms can have same subatomic particles? Second one, why is the atom of the element different from the atom of the other element? Third one, electrons are distributed, how is electrons are distributed in the space? To the answers of these following questions, we need to understand the wave nature of the light and colored flames and distribution properties. Now, first topic, spectrum. Spectrum means group of wavelengths are known as spectrum. We must have understand the observation and formation of the rainbow. We must have observed the formation of the rainbow. How many colors seen in rainbow? Total 7 colors. The 7 colors are violet, indigo, blue, green, yellow, orange, red. You can find the colors spread continuously. We can find the colors spread continuously. The intensity of each color from varies one point to another one. We can find the colors spread continuously. The intensity of each color varies from one point to another point. Now, the simple definition wave. What is the wave? Wave is the creating disturbance in medium. Suppose when you throw a stone into a pond, what we observe? Ripples are formed, which transmitting the disturbance in the form of waves. In the form of waves on the surface of water. You observe, you see the surface of the water, ripples are formed. Suppose, how sound waves are produced? When something vibrates, like a drum, rhythm, treble. You know, pleasant to hear, that is called musical note. Any sound vibrating, anything vibrate, that is the pleasant to hear, that is called musical note. Unpleasant to hear, that is called noise. Now, very important topic, explain about the electromagnetic wave. Wave nature of the light. Light is an electromagnetic wave First one, light is a electromagnetic wave. Second one, electromagnetic waves are produced vibrating electric charge. Third one, a vibrating electric charge creates change in electric field. Fourth one, that creating electric field creates change in magnetic field. Once again, is the 4 points. Light is the electromagnetic wave. Electromagnetic waves are produced a vibrating electric charge. A vibrating electric charge creates change in electric field. The creating change in electric field creates change in the magnetic field. Both creating fields are perpendicular to each other, right angle of the direction of the propagation of the wave. Both creating changes in the field perpendicular to each other, right angle of the propagation of the direction of the propagation of the wave. This is an electromagnetic wave. Electromagnetic wave characterized by the electromagnetic energy characterized by these relations. One is wavelength. Wavelength means the distance between the one wave peak to another wave peak is called wavelength. Wavelength is denoted by lambda. Units are meters, nanometers, angstroms, centimeters, etc. Next, frequency. Frequency means the number of waves passing through a unit second time is called frequency. The number of waves passing through a unit time second is called frequency. Frequency is denoted by mu. Units are hertz. One relation between velocity of the light, wavelength and frequency is C equal to mu lambda. C is the velocity of the light, is value 3 into 10 power 8 meter per second. Mu is the frequency, lambda is wavelength. One question asked from the textbook, the wavelength of the radio wave is 1 meter, find its frequency. Once again I asked the question, the wavelength of radio wave is 1 meter, find its frequency. In the question given from this question, wavelength lambda equal to 1 meter, velocity of the light (3 into 10 power 8 meter per second). You find frequency mu. You know relation C equal to mu lambda. Mu equal to C by lambda. C equal to 3 into 10 power 8 by 1. The answer is 3 into 10 power 8 oscillates per second or hertz. This is the answer. To find the frequency or wavelength, relation is C equal to mu lambda. Now, one universal relationship for all waves, we apply all waves, that is, when frequency is longer, wavelength is becomes smaller. Frequency is increases, wavelength becomes decreases. We observe the rainbow, in each color characterized a specified wavelength. Red, higher wavelength; violet, shorter wavelength. Red, higher wavelength; violet, shorter wavelength. These colors seem that human naked eye very sensitive. That's why these are called visible light. The entire range of colors covering from red to violet is called visible spectrum. Now we are going to electromagnetic spectrum. Electromagnetic spectrum, we have a variety, ranges of wavelengths, different wavelengths. The entire range of wavelength covering from red to violet is called electromagnetic spectrum. Electromagnetic spectrum synthesized or characterized by two different gamma rays have shorter wavelength. Radio waves are highest wavelength. Gamma rays shorter wavelengths, radio waves are highest wavelengths. Now, one general topic, one general question. When you heat the iron rod on a flame, what we observe? Suppose you heat the iron rod on a flame. First, what we observe? First, heat energy is emitted. Heat energy emitted means released. First, it turns to red color. Red means lower energy, higher wavelength. When you heat the iron rod on a flame, it turns to heat energy emitted. First, it turns to red, lower energy, higher wavelength. Your temperature is raised. Temperature is raised after it's turned orange, yellow, blue. That means higher energy, lowest wavelength, lower wavelength. Finally, it turns to white color, that is called visible light. You heat the iron rod, first heat energy is released, first it turns to red, lower energy, higher wavelength. The temperature is increased and raised, it turns to orange color, yellow color, blue color, higher wavelength, shorter or lower wavelength. Finally, it turns to white color, that is called visible light. When the temperature is higher and too enough, other colors released, other colors are emitted. But the intensity, due to the higher intensity, one particular emitted color, other cannot be observed. Only one is released, remaining all are not observed. That's why here energy is absorbed or emitted. Now we are going to match Planck's constant equation. The energy is the form of the packets, that is called quanta. Now one equation represented E equal to h nu. Here E is energy, h is a Planck's constant, u is the frequency of radiation. The Planck's constant value 6.626 into 10 power minus 27 erg per second or 6.626 into 10 power minus 34 joule per second. This is the Planck's constant equation, E equal to h mu. E is the energy, h is the Planck's constant, mu is the frequency of radiation. Now, for the activity 2. First activity, wave nature of light. Next one, activity 2. Take a pinch of cupric chloride, formula CuCl2, in a watch glass and make a paste with the concentrated hydrochloric acid. First you prepare the paste CuCl2. This paste is taken in a platinum loop and introduced a non-luminous flame. CuCl2 produced green color. What color you observe? Green color. Same. Now we take strontium chloride. Same process. Take a pinch of strontium chloride in a watch glass. Make the paste with concentrated hydrochloric acid, and this paste taken in a platinum loop and introduce the non-luminous flame. What color you observed? Crimson red color. What color is produced? Crimson red. CuCl2 is produced green color. Strontium chloride produced crimson red color. Now, what we observed? Did you see the street lamps? What is behind that one? Sodium vapor. Sodium vapor. This is the first topic in the structure of atom. అదే నిమిషాలు వచ్చిందా?